Good afternoon to all. My dear children, in the last class we learned about that surface chemistry lesson, intermediate compound theory, intermediate compound formation theory, homogeneous catalyst reaction. It's a very important question. One of our students asked one doubt. That particular question they are for example. We learn all for example. But my answer is, those who are interested you can learn the for example. Otherwise, at least one example you thorough it. Okay? That is my suggestion. Anyhow, today our learning objectives to learn about adsorption theory and also active synthesis, to learn about the active synthesis, the very important question about what are the characteristics of catalyst. What are the characteristics? Here, about the adsorption theory, the mainly this theory having 4 or 5 points. Only 5 points is enough. Lamier explained this theory. It is a heterogeneous catalyst reaction. Okay, about the intermediate compound formation theory, it is a homogeneous catalyst reaction. Here, it is a heterogeneous. Here, main 4 steps. One is the adsorption of reactant molecule. Second step, the formation of activated complex. The third one, the decomposition of activated complex. The fourth point, desorption of product. The 4 steps. This is included in the adsorption theory. Very important question, very, very important question. But I am giving a small diagram for this question. You should be draw the diagram also for understanding, only for the understanding. The first step, the reactant molecule, that means A and B, one of the reactant molecules are adsorbed on the surface of the catalyst. Okay? The reactant molecule A and B are adsorbed on the surface of the catalyst. The second point, second step, here formation of activated complex. The reactant molecule adsorbed on the surface of the catalyst. Next, it undergoes activated to form an activated complex. This is the second step. The third step is, here the decomposition, the step is decompose, separation. Decomposition of activated complex. The fourth step is releasing the product on the surface of the catalyst. This is the concept. So please all of you take the note. And one more, my humble suggestion. Those who are not having the textbook, please note this answer. Okay? Please all of you take the note. To learn about adsorption theory. Dear children, the last class we discussed about the intermediate compound formation theory. That is a homogeneous catalyst. Am I right? Catalyst, okay? Here, the adsorption theory. This is a heterogeneous catalyst reaction based on adsorption. Okay? Langmuir explained the action of catalyst in heterogeneous catalyst reaction based on adsorption. Okay, it's a heterogeneous catalyst. Okay, anyhow, the reactant molecules are adsorbed on the catalyst surface. So this is called an contact catalysis. Okay, contact catalysis. Sometimes you may ask like that. Contact catalysis. What is the concept of the adsorption theory? That is my question. What is the concept? That means the reactant adsorbed on the catalyst surface to form an activated complex. Here, the reactant are adsorbed on the surface of the catalyst to form an activated complex. That activated complex decomposes and form products. This is the concept. Okay, what's the question? The reactant are adsorbed on the surface of the catalyst to form an activated complex which undergoes decomposes and gives the product. That's the question. Anyhow, I think that adsorption theory having 4 or 5 points we have, okay? 4 or 5 points. What is the point? What is the first one is? Reactant molecule diffused from bulk to the catalytic surface. The first point. The reactant molecule diffused from where? From the bulk to the catalyst surface. The reactant molecule diffused from bulk to the catalyst surface. First of all, we can be, for the better understanding, I am drawing a small diagram about the adsorption theory. The first one, I told that the reactant molecule diffuse from bulk to the catalyst surface. The second point, bulk to catalyst surface. So first point. The second point, the reactant molecule. The reactant molecule are adsorbed. Okay? Reactant molecules are adsorbed on the surface of catalyst. We can consider the reactant molecule. What are the reactant molecules? We can take this AB. The reactant molecules we can be considered as a AB. AB reactant molecule for drawing. This is the surface of catalyst. Okay? This is the surface of catalyst. Okay, the reactant molecule. This is the reactant molecule. The reactant. One is the reactant molecule A. Other one is the reactant molecule B. Clear? One is the reactant molecule A. The reactant molecule A and B are adsorbed. Don't forget that. The reactant molecule A and B are adsorbed on the surface of the catalyst. The second point. What is about the second point? The second point. What is about the third point? The adsorbed reactant molecule are activated and form activated complex. Okay? Here, the adsorbed reactant molecules, this is the adsorbed reactant molecules, are activated and form activated complex. That means these two adsorbed molecules undergoing activation, okay, and to form an activated complex. That also can be drawn like that. This is the surface of the catalyst. Okay, this is what? An activated complex. Now, what is the third point? Next point. This activated complex undergoes decomposition. Okay, this activated complex undergoes decomposition. To form products. Okay? We have to draw another one. Which are the products? A and B are the reactant. C and D are the products. Okay? We have the products. Next, what is about the next point? This product we have to dissolve. Otherwise we can be say diffuse. Otherwise we can be say released from the surface of the catalyst. Okay? This product, the decomposition product undergoes, these product molecules are dissolved. Don't forget that dissolved. Dissolved. What's the meaning of dissolved? Release. Okay? That means we can be say released. We can be draw like that. This is the surface of the catalyst. Now the products are released from the surface. Okay, don't put the line here. Okay? Here. Release. The product molecules are dissolved. Otherwise called the product of diffused. Okay, or diffused. Diffused from the surface of catalyst. Okay, this is about the theory. Here, what is the first point? The first point is the reaction molecule diffuse from bulk to the catalyst surface. What is the first point? The reaction molecule diffuse from bulk to catalyst surface. The first point. What is second point? Reactant molecule. Let us consider the reactant molecule is AB. The AB are adsorbed. The reactant molecule AB are adsorbed on the surface of catalyst. Surface of catalyst. That is, those who are interested, you can draw the diagram also. On surface of the catalyst. This is the catalyst. Here, reactant molecules are adsorbed. Now adsorbed on the surface of the catalyst. What is second point? Here, the adsorbed reactant molecules are activated, are combined or joined to form an activated complex. This is an activated complex. Okay? Activated complex. They are combined, joined. The ABs undergoes joining. Okay? Joining to form an activated complex. The activated complex undergoes decomposition. This undergoes decomposition, that means splitting. Divide. Decomposition to form products. Now we get the product. The product molecules are dissolved, that means released from the surface of the catalyst. A simple concept about the absorption theory. It's a very important question. Don't forget that. It's a very important question. Okay. One of the 3 mark questions. Sometimes it may be asked to the 5 mark question answer. Okay. That's about the absorption theory. And next we have to learn about the active synthase. Okay? Already we learned about the active synthase. Active synthase. Here, this is one of the surface. Okay? Surface, am I right? The surface of the catalyst are not smooth. Okay, here having smooth surface, but anyhow, the surface of the catalyst are not smooth. Okay, it bears some steps, some cracks, some corners. Okay, so hence the atom on such a location of the surface are coordinately unsaturated. So they have much resonantial force of attraction, having some force of attraction. That's due to the force of attraction, having such a site, some area, some site are called as active centers. Okay, so the surface carries high surface free energy. Here we can be explained the presence of active centers. What is the main function here? The presence of active centers. If active centers having more, increase the rate of the reaction. Okay? The presence of such active centers increases the rate of the reaction by absorbing and activating the reactant. Okay, that's the first point. We have, I think that as per the active centers, we have some important point. The first point is increase the surface area of the metal or metal oxide by reducing the particle size. Okay, increase the acting on the catalyst and hence the rate of the reaction. Okay, increase the surface area of the metal. Increase the surface area of the metal and metal oxide by reducing the particle size. Increase acting on the catalyst. Okay, second point. About the second point, the action of catalytic poison occurs when the poison blocks the active centers of the catalyst. We learn about the catalytic poison. What is about the catalytic poison? The substance which destroys the activity of the catalyst. Am I right? The substance which destroys the activity of the catalyst. Anyhow, the action of catalytic poison occurs when poison blocks the active centers of the catalyst. Okay, next, third point. What is about the third point? The promoter. About the third point is the promoter. The promoter or the activator increase the number of active centers on the surface. What is about the promoter? The promoter is otherwise it can be said the activator. The promoter or the activator increase the number of active centers. Okay, increase the number of active centers on the surface. These are the 3 points about the active centers. And also having one more point about that, one more topic about that. What are the characteristics of catalyst? Okay, that also we should be learn. What are the characteristics? What are the characteristics of catalyst? First point. Okay, I think that we have I think have more than 7 points. Okay, so we should be learn all the points. Okay, here, what are the characteristics of catalyst? For a chemical reaction, catalyst is needed only a small quantity. Don't forget that. Okay, what's the first point? Catalyst is needed a very small quantity. Okay, here for a chemical reaction, don't forget that is a very important question for the 3 mark and also as well as the 5 mark question. For a chemical reaction, catalyst is needed in very small quantity. A pinch of catalyst, a small amount of catalyst is enough for the reaction in a bulk. Okay? That's the meaning. A small amount of catalyst is enough for the reaction in bulk. Bulk means many. A huge amount of reaction. Only a small amount of catalyst is enough. Okay. Next about the second point. There are many some physical changes. A catalyst remains unchanged in mass. Catalyst remains unchanged. Mass, okay, unchanged in mass, and also chemical composition. In a chemical reaction. Here, I told you about the first point. The first point is catalyst is needed a very small quantity. Suppose we are adding a small quantity of catalyst to a particular reaction. The catalyst remains unchanged in mass. The reaction mass cannot be increased or decreased. Or the chemical composition cannot be changed. So, if you are adding a small quantity of catalyst, the mass is unchanged, never changed. And also the chemical composition also not changed. That's about the second point. Third point, a catalyst itself cannot initiate the reaction. Third point is the catalyst itself cannot initiate a reaction. It means it cannot start a reaction. Okay, clear? If the reaction is taking place in slow rate, the catalyst can be increase the rate of the reaction. That is the function of the catalyst. The catalyst itself cannot initiate reaction. The catalyst never start a reaction. Okay? It cannot be initiate a reaction. It means it cannot start a reaction. But if the reaction is taking place in slow rate, okay? That's a condition. If the reaction is taking place in a slow rate, it can speed up the reaction. It can be increase the rate of the reaction. Clear? What's the concept? First one, for a reaction, for a chemical reaction, catalyst is needed a small quantity. A catalyst is needed in a very small quantity for the bulk of the reaction. Am I right? Yes. Second point, the catalyst remains unchanged in mass and chemical composition in a chemical reaction. The third point, the catalyst itself cannot initiate a reaction. What's the meaning of this point? If the reaction is taking place in a slow rate, catalyst can be increase the rate of the reaction. Okay, next one, the fourth point. A solid catalyst will be more effective, okay, if it is taken in a finely divided form. Okay, a catalyst, a solid catalyst will be more effective. Okay, so a solid catalyst will be more effective if it is taken in a finely divided form. Okay, when suppose you are taking a catalyst, the catalyst will be more effective. The condition if it is taken in what? A finely divided form. That means in that we can be say finely divided form means maybe it may be a powder form like that. Okay. So what are the 5 points? Can you say? What are the 5 points? Here I wrote about that 4 points. What are the points? One is the catalyst is needed a very small quantity. The catalyst remains unchanged in the mass and chemical composition. The catalyst itself cannot initiate a reaction. A solid catalyst will be more effective if it is taken in a finely divided form. Okay, next one is the catalyst can catalyze a particular type of reaction. They are said to be specific in nature. A catalyst is a particular type of reaction. The catalysts are said to be a specific in nature. Have some specific in nature. That's a catalyst. Next about the 6th point, it's a very important 6th point. What is about the 6th point? Sixth point, okay? Catalysts are highly effective at a particular temperature. Is called an optimum temperature. A catalyst is highly effective at a particular temperature. A catalyst is highly effective at a particular temperature is called optimum temperature. Okay? That is about the 6th point. And we can learn about one more point. The presence of catalyst generally undergoes not change in nature of product. Okay. The 7th point. Presence of a catalyst generally does not change the nature of product. The presence of catalyst generally does not change the nature of product. Listen, what is the meaning? I think that some of the catalysts we learn, that is the positive catalysis, negative catalysis, autocatalysis, okay, induced catalysis, homogeneous catalysis, heterogeneous. These are the catalysts we learn. Here, one of the example. What is the example means? SO2 plus O2 gives SO3. We have to balance the equation. Okay? So, make it 2 here. Equation is balanced. Am I right? Here, this reaction is a very slow reaction. That is, sulfur dioxide is converted to sulfur trioxide. Here, sulfur dioxide is converted into sulfur trioxide by the addition of oxygen. Anyhow, sulfur dioxide reacts with oxygen to form sulfur trioxide. The reaction is very slow. But what is the purpose we are adding here? We are adding one of the catalysts, platinum, PT, platinum we are adding as a catalyst. A small quantity of catalyst we are adding for this reaction. Now, the reaction is going fast. Am I right? Actually, the reaction is going slow. When we add a catalyst, that is platinum, now the reaction is going fast. So, now you understand about what are the characteristics. First point, what is the first point? The catalyst is needed a very small quantity. Don't forget that. What is about the first point? A catalyst is needed a very small quantity. Okay. The catalyst is enough for the reaction is bulk. That is a pinch of catalyst. A small amount of catalyst. Okay, is enough for the reaction in bulk. And also, second point, the catalyst remains unchanged in mass and also the chemical composition in a chemical reaction. Catalyst never start a reaction. A catalyst itself cannot initiate a reaction. It cannot start a reaction. But if the catalyst is taking place in the reaction, it can be increase the rate of the reaction. Okay? Suppose the reaction going slow rate means when we are adding a catalyst, the reaction is going fast. The solid catalyst will more effective. Okay? If what's the condition? If it is taken in a finely divided form, finely powdered form. Okay. The catalyst, as a catalyst, a particular type of the reaction, they are said to be specific in nature. Don't forget that. Specific catalyst are specific in nature. Okay. What is about the next point? A catalyst is a highly effective at a particular temperature is called an optimum temperature. Which temperature? An optimum temperature. The presence of catalyst generally does not change the nature of product. Okay? The presence of catalyst generally does not change the nature of product. For example, the reaction between sulfur dioxide and oxygen, we get sulfur trioxide. For this reaction, we have to add platinum. And the absence of platinum, this reaction is going in slow rate. Absence of platinum, this reaction is going slow rate. When we add platinum, the reaction is going fast. Okay? So, there is no change in the mass of the reaction. There is no change in the chemical composition of the reaction. Okay? So, it cannot be initiate the reaction. Only the purpose, the reaction can be increase the rate of the reaction. That are the characteristics of the catalyst. Okay? Anyhow, today I am giving the assignment. What is about assignment means? Today our learning objective about the adsorption theory. Okay? I think that sometimes it may be asked 5 mark also maybe, because intermediate compound formation theory and also adsorption theory may be asking 5 mark question. So, it's one of the very important question our today portion. So, please all of you write the assignment adsorption theory. Okay, I think that 4 or 5 point, that 5 point is enough. Okay, assignment adsorption ചെയ്യും. Okay, please all of you write the assignment. Thank you all of you. Thank you. Have a nice day.